Okay, we're going to look at applications of linear functions. Revenue, cost, and profit will be the functions that we'll be focusing on. Revenue is price per item times number of items. X will always be number of items. And you have to be given this information to find it. Cost, you've got marginal cost and fixed cost. If you'll notice, this looks like our linear equation. I like marginal because of the M for slope, and that is the cost per item. The B is fixed, and they have to distinguish between the two. Your profit function, you've got revenue minus cost, or with symbols, you've got profit equals revenue minus, and it's to your advantage if you'll put the cost function in parentheses, because if you'll notice, I've got two terms here. So in these next problems, they ask us to write a cost function for each of the given scenarios. So a trailer hauling service charges $95 plus 8 cents per mile. Anytime you see the word per, that is giving you the indication that for every mile you've got $8, and that would be the one that changes depending on mileage. So my cost here, I've got 8x plus 95, and that would be my cost function. In the next one, I've got fixed cost. Fixed cost is 2,000, so they tell me that, so I know this is equal to B. But then they come up and tell me 40 items cost 5,000 to produce. They're going to give us enough information to find what's missing, and what's missing is my marginal cost. So let me put my formula down. I've got C of X is equal to MX plus B, and I'm going to write this information in. So the fixed cost is 2,000. 40 items, that's my X. So you see, I do not know the marginal, but I do know the number of items and how much it cost to produce those. Now if you'll notice, I've only got one unknown, and I can solve for that. I'm going to subtract 2,000 from both sides. Divide by 40. And dividing by 40, I think if you'll do that in your calculator, you should have 75. So I found the marginal cost. So since the directions was to write a cost function, here it goes. So that would be what they would want. Now in the next problems, let's see. Given the following information, find the cost function. That's my A part. So I see fixed cost, I see marginal cost. So for my A part, my cost function, so there's my cost function. The B part, they want us to find the revenue. This is where the revenue comes in. This is where the money comes. So my R of X is equal to the item sells for 20. And if you look back up here for your revenue, price per item times number of items. So my revenue on this one would be 20x. C part, we've got to find the profit. So that's always revenue minus cost. So my revenue is 20x minus my cost. And this is why you've got to be careful and put your cost function in parentheses. So simplifying this, my profit function would be 9x minus 150. So in the D part, they want us to find the profit on 100 items. So 100 would be my X. So let's see. I'm going to store that. Of course, I can't see both. So 100, storing for X, and type in my function. So profit for 100 items would be $750. So that's it for that page. I've got one more page to look at. Some more terminology here. Average cost function is called C-bar, which gives the per unit cost of producing X items, is given by this function. As more and more items are produced, the average cost per item typically decreases. So in the A part, here's my cost function. My fixed cost looks like $450,000. My marginal cost per DVD is $6.80. What's the total cost of producing 50,000 and 600,000? We'll use your notation. So they just ask for total cost. So I'm going to store in 50,000. For 50,000, store that in for X. So I got 6.80X plus 450,123. So $790,000. $600,000. So $4,530,000. That's what it costs. Now here they use the word average. So now average cost, if you remember, that's a C-bar, and that's where you take your cost, divide it by the number. So for 50,000, I had that up there. So the average cost per CD for every CD is $15.80 at 50,000. Now 500,000, and we got to go find our cost first. 6.80X plus 450,123. So 385,123,4. So go ahead and divide it while it's right here. So if they make 500,000, then it's going to cost $7.70 per CD. This is per unit cost. The more they make, the smaller the average cost gets. Okay? Now, in break-even analysis, a typical company must analyze its cost and the potential market for its product to determine when or even whether it'll make a profit. A company can make a profit only if the revenue on a product exceeds the cost of manufacturing. The number of units at which revenue equals cost, that is, profit is zero, is called the break-even point. And you set your revenue equal to your cost. So the owners of a parking lot have determined that their weekly revenue and cost in dollars are given by R of X equals 80X, and their cost function is 50X plus 2,400. X is the number of long-term parkers. So find the break-even. So 80X equals 50X plus 2,400. Subtract 50X, divide by 30, looks like 80. They need 80 long-term parkers just to break even. they want us to graph this revenue and the cost. Now I'm going to use this idea about 80, and if I put 80 back in the revenue, that's 6,400. So let me go to y equals. So the blue is going to be, hopefully you can see that it's blue, and my cost. Now my window right now is the standard window. It's plus or minus 10 in both directions. So I'm going to have to change my window. Let's see, let me do an x-min of -10. Since my break-even's 80, let me go to 120. And anytime I get a larger distance between them, the tick marks, I've got to change that. So I'm going to make that 10. My y-min, these aren't supposedly getting into the negatives, but I do know that when I put 80 in, I got 6,400, so let me put 10,000 in there. And my scale, let me use 500. Let's see if we can see a graph here. Now the first one graph is my revenue. The red is my cost. Right here where they hit is my break even. If I do second calc intersect and then do enter, 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 that's my break even. So if they have 80 long-term parkers in this parking lot of theirs, then they'll just break even. They need more. Anything below that, my cost function, if you'll notice my picture, my cost function's over my revenue, and they will be operating at a loss. Now while my graph is still here, let me see what my next one is. From the graph, estimate the revenue and cost when there's 60 long-term parkers. So I'm going to do R of 60 and C of 60. If you do second trace for the calc menu and 1, I'm going to type in 60. This is Y1. If you notice right here, that's my revenue equation. And I got 4,800. It's how much money. But now my cost equation, with it being over, it should be more. So I'm going to do an up arrow to get to the other one, and that's 54. So as long as they're before 80 over here, they're going to be operating at a loss. If they can go beyond that, then they'll be operating at a profit. So that's it for this particular section. Thank you.